So now let's discuss the this option, emit particle fluid. We'll just create a sphere. Okay, then I'll move it up like this. Let me select emit particle fluid, select the object to emit particle from, select our sphere, press enter, then press enter again. If we just play the simulation, it will emit particles or emit fluids from the sphere, like as if it were a tab. Okay, so here we are emitting particles from the sphere, and if you see the setup here, it's different. There is volume source node here. Why didn't we just choose our sphere as a flip initial data here, as we did in the last videos? Okay, this initial data imports our particles or our pool particles of the tank, or our particles here of the sphere, just in the first frame. Okay, so it doesn't allow us to source from these particles each frame like that. Okay, it just imports the particles within the sphere just in the first frame, and then it doesn't import it repeatedly. Okay, or doesn't source particles from it. So this makes just our sphere to convert to an object, or to water. Okay, so to source water from the sphere each frame, we need just to create this volume source. So if we just delete this and go here to our sphere object and delete this, we can see here what are the steps to create the flip source or the source object. So we need here to create a flip source node, and here we have the voxel size, which is the resolution of our source. It creates a surface field or a volume called surface. If you middle mouse, we have a volume called surface here, and sources fluid from it. So we need just to change this to sync fluid and source flip in order to make the node readjust the parameters, like this shell thickness, which here contributes to the shell, which here makes the shell here larger or thicker. If you just try to move here like that, you will see that our sphere is just hollow from the inside. If we just disable this thickness, it will not be hollow from the inside. Okay, and it will create particles inside the sphere as well. And we have here our jitter seed and our jitter scale. So if we just move to the wireframe, now we have particles inside the sphere, and this sphere here is just the surface field, and it will use these particles. We will use those particles and this surface field to emit particles in the dot network. So we'll just create a null node and pull this out source, for example. Then let me go back here, and in the dot network, let me just we will not use it in the flip object as initial data, but we will source this. We will use this volume, the surface volume, to source particles. So we'll use volume source and change it to source flip. The sub path here, we can just here choose our outsource, then connect it into the sourcing the sourcing tab here, or the sourcing input. If we just now play our simulation, our particles will be sourced from our sphere like that. So there is a difference between using initial data, which imports particles from the sub just in the first frame and solves for those particles, and this is different from the volume source, which sources the particles each frame, which we can use as a source of particles in the waterfall simulations. Maybe water just going from a tap, okay, or dropping from a tap. And this is the purpose of this emit particle fluid, which is very different from fluid from object. And we here have a flip tank, which can create pool of objects. I hope you are now more comfortable with working with DOPs, and don't forget the difference between RBD object, which is affected by the gravity, and the static object, which is not affected by the gravity. The RBD object that is affected by any force. If we just put forces other than gravity, it will be affected by it. The static object will not be affected by these forces. So this is for this video. Thank you for watching. I hope you enjoyed this video. Wait for me, the next videos.